Hi, I'm Henry Brill, and this is SYWV01. Um, yeah, so we're doing problem 2 because I have a even ID. All right, so I wrote the question out and I wrote the 5 steps. So the first step here is turning it into a homogeneous equation, which is where just the right side equals 0. So y prime plus tan x y equals 0. All right, so that's the first step. And now this is a separable differential equation. Since we could just turn this into dy over y equals negative tan x dx. That's, we go through the process of turning the y prime into dy dx. And then we first have to, subtract this to the other side. Then we divide both sides by y, multiply both sides by dx, and boom. That's how we get this. All right, now we can integrate both sides. And this ends up working out to be an ln absolute value y equals which, so this then turns into ln the absolute value cosine x, and the negative turned into an exponent, which turned secant into cosine. All right, and then we have to add c. All right, so now we get our integrating factor thing, or solutions like the homogeneous as y cosine x. Because you raise to the e, and then it's all to the e, and this. Here, wait, let me just draw this out. All right, so then we get so we'll have an e here, so this just boom, and then e here, but there's parentheses. So this goes in front, and we just call it, a constant. This would be e to the ln cosine x times e to the c, and we could just call e to the c some other constant, so a. That's where I'm getting that from. So then this would cancel out, and we get e to the cosine, or sorry, no, the e cancels out. You just get y equals a, which is our e to the c constant, and then cosine x. All right, good. All right, so now we do like the step 2 variation of parameters. So we could just let y equal we'll just say v, and then times cosine x because of our solution to the first thing. So the homogeneous. So well, I mean, I guess I don't know. You can call that what we call it u. I guess I accidentally called it y, but it's a different y, just to be clear. And then once we have this, we have to find y prime. So then y prime equals, and using the product rule, 1 prime 2, 2 prime 1. So we get v prime cosine x and then plus 2 prime 1, so negative sign, so yeah. And then, because it's negative sign, so v sine x. All right, now we could substitute this into our original equation for y prime. Let's revisit that here. We got y prime tan x, so we can resubstitute y and then y prime, and we remember y is just let me rewrite y is just v cosine x. Oh, I guess I already have that right below. Okay, ignore this. All right, cool. So substituting this into our original equation, which you just saw, we got y prime, so v cosine x minus v sine x, and this is parenthesis, a bit more clear. So that's the y prime term. Then we have plus tan xy, so tan x, and then remember for y, we could just use this substitution, v cosine x. Boom. All right, and then equals sine x. Boom. All right. And now we solve this for v, so which first means we have to solve for v prime. So by doing like algebra, we first get v cosine x, then we have minus v sine x, and we have to remember that tan is just sine over cosine, so this just turns into, so the cosine cancels out because it's on bottom, divides, multiply and divide, so this is just v sine x. All right, cool. And now these negative positives, these go. We get v cosine x equals sine x. This v prime cosine x. Yeah, and then this is also v prime, and this is normal v. Sorry, I lost that. All right. Then we divide, try to isolate v prime, so divide both sides by cosine x, which is just tangent. So we know v prime is tangent. All right, so now to find v, we integrate both sides, and the integral of tangent is just negative, I think it's negative ln cosine x plus c, and then so this is our v, and now we put this back into our original, y equals v times our homogeneous solution, or VU, whatever, I think that's what we call it in class. So y equals negative ln cosine x plus c times, and then cosine x, which is the solution to our homogeneous. Boom. All right. Okay, now this is our, that's it. This is our general solution. Yeah. So now we apply our initial condition, which was y of 0 equals 1/2. So, 1/2 negative ln, and then we got cosine of 0, which is just 1, so I could just write this as 1. Negative ln of 1, and then that's just 0, so plus c, and then times cosine 0, which is just 1, so 1c. This just comes down to c, and this is 0, so 1/2 is c. Now I can plug this back in, and we get y equals negative ln cosine x plus 1/2, and then parentheses around here, and then times cosine x. Boom. And this is the solution. And then graphing it, coming over here. I already plugged it in. I have to hide this. But yeah, so this is it. This is just, I distributed it. But yeah, same thing. And then same equation. And then we can see that this is, we're free to move this around. This is like a slope field at a point. There's some set ones, and then we can drag this one around to, verify our answer. So if we drag it to some point, the slope should be the same as this line right here and the graph. So we see, let's drag it right here. We see it's like a tangent line to the slope. Boom. It's looking pretty good. So yeah, this is a solution. We could verify that with the graph. Let's see, and we, graph our solution, and we typed in our, it definitely, we fits the slope field. Can confirm because we can see that the slopes at the point of the graph match, or like tangent lines, and then they match the slope of the line. Cool. Well, thank you.